Hello everyone. I'm Dr. Saurabh Saxena, working as Assistant Professor in Department of Applied Science and Humanities, ABES Engineering College, Ghaziabad. So the topic for today's discussion is the application of Dirichlet's integral to find area and volume of the figures. So here we go with the concept of area and volume. The basic formula for area and volume is given as area is equals to double integral dx dy over d, where d is the region of which area is to be evaluated, and the formula for volume is triple integral dx dy dz over the volume v, and where v is the region of which the volume is to be evaluated. The thing that to be noted here, that in the form of the area in two dimension, there is no integrand, it is considered as 1, and similarly in case of volume and three-dimensional integral is used, then there is integrand as 1. Means we must remember the two formula, double integral dx dy for area and triple integral dx dy dz for volume without integrand. So here we go with the problems that will illustrate that how Dirichlet's integral is useful in case of area and volume. So first we go with the concept of area. The question is, find the area of the region in the first quadrant bounded by the coordinate axis and the line x plus y equals to 1. That is, we have to find out the area bounded by the coordinate axis. Coordinate axis means here it is x-axis, y equals to 0. This is your y-axis, and the equation of which is x equals to 0. So these are the coordinate axis, and the line x plus y equals to 1 may be plotted as this. This is x plus y equals to 1. The intercept on x-axis and y-axis are 1. So the region which is being bounded by these three lines, region R, area of this region R is to be evaluated. Now what is the formula for this? The same. Area is equals to double integral dx dy over the region R. Now think for R. What is R? R is x positive, y positive, that is the region is on the right of the y-axis, that is x positive, above the x-axis, that is y positive, and x plus y is less than equals to 1. Down the line, x plus y equals to 1. Can we write this as a is equals to double integral over r x to the power 1 minus 1 into y to the power 1 minus 1 dx dy. Why I have done this? Because I mentioned that in case of Dirichlet's integral, if we want to make use of, then two things must be in the same way, same form. That is the function integrand. It must be in the form of x to the power something minus 1, y to the power something minus 1. So since here there were no terms of x and y, we wrote it as x to the power 1 minus 1 and y to the power 1 minus 1. It will make no difference because x to the power 0 and y to the power 0 will be 1. And the region R is x positive, y positive, and z positive. Now we have got the concept of Dirichlet integral, that in this case where the function is also resembling the functional form of Dirichlet's integral and the region is matching with the region of Dirichlet's integral. So by Dirichlet's integral, the answer of this particular question may be written as gamma L, that is gamma, yeah, this is something, this is your L, this is your M, something minus 1, something minus 1. Gamma 1 upon gamma 1 plus 1 plus 1. That is 1 by gamma 3, and this is gamma 3 means factorial 2. The answer is 1 by 2. So this is the beauty of the Dirichlet's integral, even without not doing the integration actually. Here we haven't integrate, we made use of Dirichlet's integral directly in the formula gamma L gamma M divided by gamma L plus M plus 1. This is the second question to illustrate the same. Find the area of the circle x square plus y square equals to 1 in the first quadrant using Dirichlet's integral. Again, we have to find out the area. Area formula is double integral dx dy. R is defined for x positive, y positive, and x square plus y square is less than equals to 1. Here two conditions are matching, but the third one is not matching. So what we'll do? We'll assume x square and y square as the new variables u and v. So let x square is equals to u. We get x is equals to root u, and dx is equals to 1 by 2 u raised to the power minus 1 by 2 du. Similarly, let y square is equals to v, y is equals to root v, and dy is equals to 1 by 2 v to the power minus 1 by 2 dv. And the formula for area is double integral. Now in terms of xy, in place of xy, we will be having now u and v in the system. So I'll be getting dx, the value is 1 by 2 u raised to the power minus 1 by 2 du into 1 by 2 v raised to the power minus 1 by 2 dv over the region r dash. The name of the region is changed because r was the name of the region in xy system, and here the integral is now in uv system. So the name of the region is r dash. We mention r dash is defined for u positive, v positive, and u plus v is less than equals to 1. See, if x is positive, then u will be positive, y is positive, then v will be positive, and x square plus y square means u plus v is less than 1. So what we get? We get area is equals to 1 by 4 double integral over r dash u raised to the power 1 by 2 minus 1 v raised to the power 1 by 2 minus 1 du dv. And the answer of this may be given as 1 by 4 gamma L by Dirichlet's integral, gamma m divided by gamma L plus m plus 1. So this is 1 by 4 root pi, and it will be 1 by 2, 1 by 2, 1, and 1, 2, gamma 2. Gamma 2's value is 1. So I'll be getting pi by 4 as the answer. Okay. Next one is for volume. How Dirichlet's integral is important in case of volume. So the question is, find the volume of the ellipsoid x square upon a square plus y square upon b square plus z square upon c square equals to 1 in the first octant. Now, volume may be represented as v, triple integral dx, dy, dz over the region D. Here D is defined for, see, in the first octant, first octant is positive octant. So for which x will be greater than equals to 0, y will be greater than equals to 0, z will be greater than equals to 0. And x square upon a square plus y square upon b square plus z square upon c square is less than equals to 1. Here again, if we want to make use of Dirichlet's integral, then the region, the fourth condition in the region must be in the form of u plus v plus w or x plus y plus z. So what we'll do, we'll again do the same job that has been done earlier. We'll consider let x square upon a square is equals to u, and this gives x is equals to a root u, and this gives dx is equals to a by 2 u raised to the power minus 1 by 2 du. Similarly, let y square upon v square is equals to v, and this will give you dy is equals to v by 2 b raised to the power minus 1 by 2 dv. Similarly, let z square upon c square is equals to w, and this gives dz is equals to c by 2 w to the power minus 1 by 2 dw. We'll put these values here, dx, dy, dz. We'll get the volume as v is equals to, see, a by 2, b by 2, c by 2. We have to write the values like triple integral over d dash a by 2 u raised to the power minus 1 by 2 du v by 2 v raised to the power minus 1 by 2 dv, c by 2 w raised to the power minus 1 by 2 dw. And mention here d dash is for u positive, v positive, w positive, and u plus b plus w is less than equals to 1. So we get the volume as a b c by 8 triple integral by d dash, triple integral over d dash, u raised to the power 1 by 2 minus 1, v raised to the power 1 by 2 minus 1, w raised to the power 1 by 2 minus 1, du, dv, dw. And now again, we have an idea about the Dirichlet's integral. Here the integrand is again in the same form. The region is in the same form. So by Dirichlet's integral, the value of this integral may be directly written as gamma L, gamma M, gamma N divided by gamma L plus M plus N plus 1. So this is ABC by 8 root pi upon gamma 5 by 2. This is ABC by 8 pi root pi upon gamma 5 by 2 may be written as 3 by 2, 1 by 2 into root pi cancel, 2 to the 4, 2. We'll be getting pi a by c by 6. And this is your answer. So this is how beautifully Dirichlet's integral gives the value of few complicated integrals. If we don't apply Dirichlet's integral, then this integral is going to be very lengthy, as we have to put the limits of x, y, z variable limits. So the integral will be a bit complicated. But Dirichlet integrals makes it easy. We don't even need to integrate. We have to directly put the values in the formula. So these are the references. Disclaimer. Thank you very much.